Welcome to this tutorial on velocity diagrams. Today we'll explore how to analyze the motion or mechanisms using velocity diagrams, focusing on a practical example. In this example, we have a crank O1A rotating at 650 revolutions per minute. Our goal is to find the linear velocity of the slider C and the angular speed of link BC. Dimensions are provided as shown, and the diagram shows the configuration of the mechanism, including the 60-degree angle and the fixed distances like 70 millimeters between O1 and O2. So let's tackle this problem step by step to determine the linear velocity of the slider C and the angular speed of link BC. Now we have a 4-bar linkage mechanism that rotates. The crank O1A rotates, the coupler AB, a link BC, and a fixed link O1, O2, which is grounded. And the slider C is constrained to move horizontally. To solve this, we start by drawing a space diagram as shown to represent the mechanism's geometry. Next thing we do is to determine the velocity of point A with respect to the fixed point O1, and we do that by calculating as shown, where we multiply the angular velocity converted from the revolutions per minute given with the length of the link AO1, and we get a value of 2.042 meters per second. Once we've done that, then we need to draw the velocity diagram to scale as shown, and I'm going to walk you through how we do that. So first thing we select is the fixed points O1, O2, and with the magnitude of the velocity of the prime moving link AO1, which is given as 2.04 meters per second, we draw the velocity of vector A perpendicular to the link AO1 as shown. And then from the tip of the velocity of A, we draw a line perpendicular to the link AB. And this is going to represent the velocity of B with respect to A in that direction as shown. Now, from the fixed point O1 and O2, we know that the slider moves in a horizontal direction. So there we also now draw from the fixed point as shown, we draw horizontally, and where the AC meets O1C is our point C, which now therefore O1C will represent the velocity of the slider. Finally, we also draw perpendicular to BO2 from the fixed point, the vector to represent the velocity of B. Now, having done that, we completed our velocity diagram. We can now measure from our velocity diagram, and by measurement, the velocity of the slider is given as 0.7 meters per second, and the velocity of C with respect to B is given as 0.65 meters per second. Therefore, the angular velocity of B with respect to C is equals to VCB over BC, which is equals to 13 rads per second, and that is our answer.